Welcome to my channel Physics Fun. Physics Fun. Physics Fun. Today we will learn the Newton's part of the chapter friction. We know about the friction. In the nature, we see that when we are working a something force in the contact of our shoe and the floor acting in the backward direction that of the forward direction of our water. Also we can see that when there is cold, rubbing our hands, that we see that the heat energy is produced. There is something force that will create the heat energy, that will create the heat energy. Now from this we'll come to know about the force. That force is the frictional force. That force is the frictional force. Now what is friction? What is friction? What is friction? It is a horizontal plane. On a horizontal plane, we keep a block, wooden block. This is wooden block. If we apply a force parallel to the horizontal plane, it will tend to move or will move. It tends to move in that direction or it will move. Then there is a force in between the surface of the block and the plane acting in the opposite direction of the applied force. That force is the F, that is the frictional force. Frictional force, that is the frictional force. Now as the frictional force comes into play, we have to know about the cause of the friction. Cause of the friction. Here we discuss the modern concept of the frictional force. Let us write modern concept of cause of friction. Cause of friction. Cause of friction. Now let us consider two blocks or the two surfaces. At the macroscopic levels, we see that it is a smooth surface. But in the microscopic level, there is the unevenness both of the surfaces, and it is inverted by F.P. Bowden. F.P. Bowden. F.P. Bowden is the modern concept giver of the cause of the friction. Now as there is the unevenness, the contact of surface between two surfaces is very low. It is 1:10⁴. Now draw the figure. Draw the figure. This is the one surface. Underneath, this is another surface. Another surface. Okay. When it is on the over of it, there should be a force due to mg, or it may be the external force. And as the force acting on that tip point, because its area is much less, the pressure comes into play. That pressure should be greater. As the pressure is greater, so there is something, the plasticity property is seen here. As the plasticity property is seen here, there should be a cold shielding. Cold shielding. There is a many number of contacts, though there is the cold shielding. When that surface try to move in that direction, the cold shielding will oppose its motion of direction. So the cold shielding is the main cause of the friction. We understood, students? We understood. Okay. Now we know what is the cause of the friction. Now let's move. To the type of friction. The type of friction. Type of friction. So the type of frictions are number one. What is number one? Static friction. Number two is the dynamic friction. Dynamic friction, or it is known as the kinetic friction. Kinetic friction. Kinetic friction. Now the dynamic friction is divided into two parts. Number one is the sliding friction, and number two is the rolling friction. Rolling friction. Okay. Now let's move to the static friction. What is static friction? Let's move to the static friction. Static friction. An object is kept on the horizontal plane. This is the horizontal plane. A, B. This is the block C. By giving a force horizontal to the surface, that is F, if we apply the force, it will tend to move, but in the static condition, it will tend to move. In that case, a frictional force acting to the contact of the two surfaces, Fs, is called the static friction. Static friction. Now, this is a static friction. When we apply the force, increasing the force, the Fs is also increases. As F increases, Fs also increases. At the moment when it will resume to move, at that position Fs is maximum. That is, before it moves, the frictional force before it moves is called the limiting friction. That is called limiting friction. Now, what are the laws of the limiting friction? Laws of the limiting frictions. Number one, in direction on which the force is applied, limiting friction acting in the opposite direction. This is number one. Number two, it acts in between the contact surfaces of two objects. Number two. And number three, it never depends on the area of contact. It never depends on the area of contact. And number four, it depends on the nature of the plane or the nature of the objects. As take the example, this is a floor, this is a dry floor. We can work easily, but if we put some oil on it and step on the wall, we will certainly slip. We will certainly slip. Why? Because the frictional force is reduced. Because the frictional force is total frictional force is reduced. So we understand that the nature of the flow is a vital cause of the increasing or the decreasing of the frictional force. Now let's move coefficient of static friction. Coefficient of static friction. What is the coefficient of static friction? Let us consider it a horizontal plane on which a block is kept. Weight is acting in the downward direction and a reactional force created due to the weight on the floor. And a frictional force Fs acting in the opposite direction to the force applied Fs. For the laws of the friction, static friction, that was written. The static friction Fs is always proportional to the reactional force. So Fs is equals to mu s into r. What is mu s? Mu s is the coefficient of static friction. So mu s can be written mu s equals to Fs by r. What is the unit of mu s? There is no unit of mu s, the coefficient of the static friction, because it is the ratio of the two same physical quantities. Two physical quantities. Now let's move angle of friction. This is the angle of friction. Angle of friction. The angle of friction. Again we consider a block kept on the horizontal surface. Its weight acting in the downward direction, vertically downward, and a reactional force acting in the vertical direction perpendicular to the plane of the surface. Now this is the applied force F and this is the frictional force Fs. Now let us consider a resultant of R and Fs. R and Fs is S, and this resultant making an angle lambda with the reactional force. That lambda is known as the angle of friction. That lambda is known as the angle of friction. Now, if you resolute S cos lambda, and this is S sin lambda. Now here we have R is equals to S cos lambda. It is in the vertical direction and R is also in the vertical direction. All students understood that. Now the Fs is equals to S sin lambda. Now making the ratio of that, we have mu s. Mu s is equals to Fs by R. And what are the values of the Fs and R? The S sin lambda by S cos lambda, that is equals to tan lambda. So here we have the relation mu s is equals to tan lambda. Now let's move to the another topic. Angle of repose. Angle of repose. Angle of repose. Let us consider inclined plane. Let's make an angle theta. Over it a block is kept. Over it a block is kept. It is tending to sliding down. It is tending to sliding down, but it is not sliding at that moment. This is mg acting in the downward direction. This is theta, that angle is theta. So this is mg cos theta, and this is mg sine theta. Now the reactional force is R, and Fs is acting here. Now from the equilibrium condition, what we have from the equilibrium condition is the Fs is equals to mg sine theta, and R is equals to mg cos theta. So mg cos theta. Now taking the ratio of both, we have mu s is equals to Fs by R. Now from here we have mg sine theta by mg cos theta, that is equals to tan theta. That is the relation of mu s and tan theta. That is the angle of repose. Now what is the relation between the angle of friction and angle of repose? The relation between angle of friction and angle of repose. Angle of friction and angle of repose. We know the relation mu s is equals to tan lambda, and mu s equals to tan theta. Now here we have tan lambda is equals to tan theta. So lambda is equals to theta. This is the relation. Angle of friction is equals to the angle of repose. Now let's move towards the kinetic friction or the dynamic friction. Kinetic friction or dynamic friction. ये क्या है? What is that? An object moving on the horizontal surface. So reactional force is applied. So the body is moving. A frictional force acting in that case is the Fk. Fk is the kinetic friction. And here the laws are same in the static friction case, where we have Fk is proportional to R. So we have Fk is equals to mu k into R. What is mu k? The coefficient of static friction. Coefficient of kinetic friction. Coefficient of kinetic friction. So we have mu k equals to Fk by R. Now let's draw. Okay. Now let's draw a graph regarding the force applied and the frictional force. Here is the force applied along the x-axis and along the y-axis is the frictional force. Frictional force. Now from the static friction we see that as we increase the external force, the static frictional force also increases. That is the self-adjusting force. Now here the graph should be a straight line. Now at the limiting friction it is maximum, then it falls, and that becomes that kinetic friction. It is moving in the with the uniform velocity. That represents the limiting friction. Limiting friction. The kinetic friction. Kinetic friction, and that is the static friction. Static friction. That is the static friction. Okay. Now, here we are going to make a relation. We know that F is should be less than equals to the force applied. We know that. Okay. Now here we know that mu s is equals to Fs, that is static friction, by R, reactional force, and mu k is equals to Fk by R. Now taking the ratio, mu s by mu k is equals to Fs by Fk. Okay. Now here the static friction should be greater than 1. So here mu s is always greater than mu k. Okay students, that is the relation we have created here. We are going to discuss about the rolling friction. The rolling friction. What is rolling friction? When some object or balls or the wheel moving on the surfaces, it will compress, and that compression creates the rolling friction. बचपन की यादें. Let us remember when we are sitting on a cart and the cart is moving on a muddy path. The wheel of the cart certainly compresses the muddy path, and it will give a rolling friction. And when we move our motorcycles, the wheels and the tubes of the wheels also compresses and creates a frictional force. So please take care of the wheels pressures. Like, okay, now the rolling friction. Now the laws of the rolling friction. What are the laws of rolling friction? Now what are the laws of rolling friction? Rolling friction. This is a wheel, and the radius of the wheel is r. It is moving over a surface, and a reaction force acting in the upward direction vertical to the plane surface. So the rolling friction is directly proportional to r. That's the reactional force, but it is inversely proportional to the radius of the wheel. So combining that, Fr is proportional to r by r, and that is Fr is equals to mu r into caps r by small r. This is the relation. That is the relation. Now let us discuss the method of reducing the rolling friction. How to reduce the rolling friction? If we are lubricating the contact surfaces, that is the wheel, we can reduce the rolling friction. Use of the alloys. If we use the alloys, that will create less frictional force before. And use of the ball bearing. This is the ball bearing. If ball bearing is using, then when the wheel is moving, all the balls are rotating in the counterclockwise direction of the wheel moving in the clockwise direction. So it will reduce the frictional force. Now, find the acceleration. Find the acceleration of an object sliding down along an inclined plane. Let us consider this is an inclined plane. Okay, making angle theta. This is the object sliding down. When it is acting in the downward direction, a reactional force perpendicular to the inclined plane. Now, which force is responsible to make it sliding down? Is the mg cos theta, and mg sin theta is responsible. And a frictional force Fk acting in the opposite direction to the mg sin theta. Now the resultant force F is equals to mg sin theta is greater than R. So mg sin theta minus Fk. mg sin theta is greater than Fk. Now here Fk is equals to mu k into R. Now what is R? R equals to mg cos theta. Now putting it, mu k mg cos theta. Now replacing Fk by that, we have F is equals to mg sin theta minus mu k mg cos theta. Now take the common out, as the mg is the common, sin theta minus mu k cos theta. Okay. Now here the acceleration, where the acceleration A is equals to F by m, that is equals to mg into sin theta minus of mu k cos theta by m. M will cancel out. G into sin theta minus mu k cos theta. That is the acceleration with which it slides down. Okay.